Hi, my name is Jessie. Welcome to Pyjamas Comp. So, to introduce myself, I am an algo engineer working at Hudson River Trading, which is a high frequency trading company based in New York. And part of that, I worked at Google for 6 years on Google Search, Google Maps, Google Drive, doing front end and back end work. So, that's kind of my background. And so, today we're going to talk about unit testing. Um, so, the way this presentation will work is first, we're going to talk a little bit about why you should write unit tests. Like, how is it going to benefit you personally? Then we'll talk about what are the best practices for writing unit tests. And finally, we'll go through some Python features that will make it very easy for you to accomplish those best practices while writing your unit tests. Okay, so I hate writing tests. Everyone hates writing tests. I'm going to try to convince you to do it anyway. So, how does testing benefit you? Good testing increases the lifetime of your code. So this is for a variety of reasons. As we write code, there's this concept of like legacy code, and it's code that doesn't necessarily work all the way anymore, and it's bad for like a variety of reasons. And you can try to prevent your code from becoming legacy code by writing tests. So people are going to have to improve your code if they break it because there is a test telling them that they cannot land their change. So that is really going to help your code last a longer period of time in a good state. Um, Also, like as people are doing maybe like migrations, they're like converting from Python 2 to Python 3, they're upgrading pandas, and people are going to need to make these changes throughout the entire code base. They're going to be making changes to your code potentially. And so not only is your code less likely to break when that happens, which is going to make it longer lasting and more reliable, but in general, it's a little easier to get other people to do that work because your code is well tested. So your code is just going to be more up to date as people make these changes in your code base because other people are more confident making changes to your code because it is well tested. If the code is not well tested, that's the kind of case where people are like, hey, you're going to have to upgrade pandas in your code because I have no way of knowing I did it correctly. So yeah, you're just like getting ahead of the game here, making other people handle your work for you and increasing the lifetime of your code. The next thing I'll say is that good testing increases the impact of your code. So people are more likely to use your code if, for one, it's reliable, but also if it's just if it's well tested and maybe they need to add new features to your code. They're like, we want to integrate with your code, we want to use your API, but there's a few things we need, and can we add these ourselves? Yes, if your code is well tested, they can add them themselves and they're going to feel much more confident doing that. Additionally, people are going to be more comfortable integrating with your code because tests serve as really good documentation for the code. They are essentially copy and paste examples of like how the code works. So that is great for getting other users like on the systems that you're writing. Good testing lets you take on more projects. So you've created this really impactful project that has a really long lifetime, and so now you're stuck maintaining it. So how do you get out of spending too much time maintaining your code so that you can take on other projects? So one, you get new hires to work on your code, or other developers, and other developers are going to ramp up on your code much easier because your code is well tested. They're going to feel more comfortable making changes. They're going to feel more comfortable like moving to larger and larger feature requests because they're less scared of breaking the code. Additionally, your code is just going to break less often because there are tests. And so that is less maintenance work for you. If you write tests now, you're really setting your future self up for not having to spend forever maintaining it. So that is my recommendation. So for this talk, we're really only going to focus on unit tests. And so just because we only have 25 minutes. So there are a lot of different types of tests. I'm really only going to talk about two right now. So one is unit tests. That is a very small and self-contained piece of code that is being tested. So for example, typically it would be just one chunk of code inside one class. If that code calls other classes, you're not testing what those other classes do. You're just testing the small chunk of code. And because it's so small and self-contained, it's very fast to run these tests and it's easy to debug because if it fails, you know exactly where the error is. There's just not that many other places the error could be. Integration tests is kind of the next step up in terms of making your tests bigger and bigger throughout the system. So that is going to test the way that different chunks of code work together. So it may go through a path of multiple different classes. So these are still important, and you can even get bigger and bigger but that is not what we're talking about. We're just talking about unit tests today. And so I just want to make sure we're like clear about what that means and that it is not the only kind of test. So what makes a good unit test? I have 5 things I'm going to talk about what makes a good unit test. So 1, unit tests should clearly explain what behavior they're testing. So I'm going to have 3 different examples here on ways to do that. So our first example, we have these functions, and each function is named very clearly. So we have test get username where account ID is none. Test get username where the account ID is in the database. Test get username where account ID is not in the database. And so it's very clear what each of these tests is testing. This means that anyone reading through your code who is like, I wonder what happens if the account ID is not in the database, they're going to find it pretty immediately. And if something breaks and you see, oh, there's an error being thrown in test get username account ID not in database, like you know exactly what the problem is right away. So being very clear about what your tests are doing is really going to help you out. So other ways to do this. Adding comments. Why won't my slides change? There we go. Okay, adding comments to your tests. So sometimes people like to put all of the tests related to maybe get username into one test. That's a perfectly fine way to organize your tests. If you do that, I recommend adding comments so that every assertion you're doing, it's very clear what it is that's being tested. Even better than that, I recommend using very good variable names and test like strings or like test objects. So to show what I mean by that, so we have in here, if we call get username on the string valid account ID, it's pretty clear to someone reading this, like we're checking what happens if you get a username when you have a valid account ID. If we call get username with the string invalid account ID, it's pretty clear what's going on, and we can see, oh, and it throws a value error in that case. So you can combine all 3 of these. You can have great, like well-named tests with lots of comments and good variable names. Absolutely do all of it. But those are like different ways that you can just make sure that it's clear what your unit test is testing. Number 2, unit test should cover all edge cases for each public function. So I really want to, we'll go into the public function thing later, but for all use cases and edge cases. So we have this example function, play tic-tac-toe move. It takes in a player, it takes in an X and Y coordinate, and we want to write a test for this function. The function returns a Boolean indicating if the player won the game or not in response to the move. So when thinking about this, I'd really recommend you think about what are all the valid use cases for this function. So in this case, in a tic-tac-toe game, you can win horizontally, you can win vertically, you can win diagonally, you can play a move and just not win. Those are all valid ways that this function could be called. And so those are all things that need to have their own test. There are also invalid inputs. For example, the player that moves is not one of the players in the game. You place a piece on a square that's already been played on, or you place a piece, but the game has already been won by some player. So these are all things that, that's not the correct way to call your function, and you want to make sure that you're throwing the correct exception in those cases. 3, unit tests should test all public-facing functions and avoid testing private functions. So let's take a look at this example. We have this public-facing function, remove odd numbers. It calls a private function is even. We only want to test remove odd numbers. We do not want to call is even. We only want to test that remove odd numbers does the correct thing. And if it uses the private function is even to do that, then great. All that matters is that, for these inputs, we get the correct outputs. The reason you don't want to have a test that's called something like test is even function is because it's really more of an implementation detail of remove odd numbers, and you are not testing implementation details. If someone refactors the code, you don't want your test to break. If your test breaks due to a refactor that does not change the logic of the code, like the same inputs are still giving the same outputs, you just shuffled stuff around a little bit and now your test is failing, that's a false negative test. Like your test is failing even though nothing went wrong. And when people get those a lot, they start not trusting when they see test failures. They're like, oh, well, things fail all the time and it's nothing. And you don't want that. So, be very careful about testing the correct things so that you don't test things that, are not don't test implementation details. Okay, number 4, unit tests should contain as little logic as possible. So I really like this. So we have this function, have same domain names, and we're going to write a test for it. So in our test, we have these different domains and these different pages, and we combine them into strings, and then we call have same domains on it. So if you looked at this function, you would probably think that what is being tested is that we are calling have same domains on the strings google.com/maps and google.com/calendar. And we're confirming that they are equal. That's what the assert does, and it's returning true. That is actually not what this does. There's a bug hidden in this test. And we will see on the next page what that looks like. So what we have actually created are the strings /maps and /calendar. And that's because os.path.join does some kind of weird stuff when you have slashes in the strings. So, this test is going to pass, but it's also going to pass in a lot of cases where it shouldn't, where like you break have same domains and it keeps passing. That's not great. This is going to cause a lot of bad tests. So what I recommend doing instead is to be very explicit, very verbose about what it is you're testing. So rather than like constructing these strings, you should just pass the string in directly. In this particular example, we started out with a long function and we ended up with a short function by the end. That is usually not the case in real life. In real life, typically the reason you're adding logic to tests is because your test is super long and it contains a lot of duplicate code and it makes you sad to look at. So you go and add a bunch of logic to try to like shrink the test and make it a little just like more concise and less duplicated. And that instinct makes sense when you're working with like real code, but it is not the instinct you want when working with tests. Because introducing logic is where we get bugs from. And if there's bugs in your test, we've ruined the point of the test. We can't test the test. So you really want everything to be extremely clear. In addition to that, it really serves as better documentation. In the previous example, I would kind of have to think pretty hard about what it is that's being tested. In this example, it's extremely clear without having to dig into the code at all. And that's great. It's very self-documenting. It's very clear what's happening. It's a lot harder to introduce bugs. 5, unit tests should not test code outside the scope of the test. So the text on these slides, we're actually going to dig into a little bit on the next section. But the main thing I will say is, so we talked about we want our unit test to test like a little small chunk of code, right? Very self-contained. So we need to keep it self-contained, and that's something we need to figure out how to do. And typically you do that by mocking stuff out, which is a thing we're going to learn how to do. So in this particular example, we have this function get username that is making an HTTP request. Making an HTTP request in a test is bad. Do not do that. It's going to be slow. It's going to be flaky. Your network connection goes down and now your test is failing, but like that's not what you're testing. You're not testing your network connectivity. You're testing the logic in the code. And so you just made the scope too big and it's going to slow it down a lot. So that's the kind of thing that like is outside the scope of a unit test. And really calling into any other class is usually outside the scope of a unit test. So let's go a little more into detail about how you would mock something out though, if you wanted to. So Python testing tips. This is that same function, but bigger. We get username. It takes in an account ID, which is a string. It uses that account ID to make a request.get HTTP request. It passes it in as a parameter, and then it gets the response. It confirms that the response is successful, and then it gets the JSON out of the response and checks the username and sees what it is and returns that. Okay. I also want to call out, this is located in our module project.data.fetchData, which is going to be important on the next slide. On the next slide. So we're going to learn how to patch things. So unittest.mock has what is called a patch decorator. And so when you put a patch decorator on top of your test, what it is going to do is it's going to find the function located at that location. And so it's going to go into the module project.data.fetchData and find the function request.get. So you have to construct that string referencing the exact location of the function you want to mock out correctly, or it will not mock out the correct instance of the function. So that is why it's important to know what module the code that we're testing is in. So when you do that at patch, it's going to automatically inject a parameter into our test. And so the parameter has injected, we're going to call mock client get, and it's of type magic mock, which is just what gets injected. On a magic mock, so mock has a few different attributes. One of those attributes is return value. When you set the return value, that represents whenever client.get or request.get gets called, it's going to return this return value object. So you can set attributes on that so that if you want to access it, you can. So, and on the previous slide, let's go up to it, we access, request.get returns a response, and then we access response.ok and response.json. So in our return value, we need to set OK and JSON. So functions on a mock will always return another mock. And so that's why when we're setting the JSON attribute, that's a function. So we need to set that function's return value. And we set it to this dict username to name1. What this does is on the next line, when we call get username with 00243, it's going to call our get username function, but when the code gets to request.get, it's not going to do a request.get. It's just going to automatically return this mock that we've created. And so then when we try to access the mock's OK parameter, it says true. When we try to access the mock's JSON function, it returns username name1. And that's actually going to happen no matter what you pass in to get username. So we should figure out how to be a little pickier about that. So the next thing we'll talk about is side effect. So, you have your return value where you can say what you want to return, but what if you don't just want to return something? What if you really just want to replace it with a whole function? So you can do that with side effect. So side effect, you set equal to the function that you want to replace requests.get with. And so we have replaced it with this fake get function. Inside of fake get, we make a mock, we set those attributes on it, and we return it. So these two slides do the exact same thing. But what if we want to do something cooler than the exact same thing? Maybe we want to check that the parameters it was called with are correct. So at the top of the side effect function, you can see that, we take in the URL and parameters because that's what request.get takes in. And we are asserting that they are what we expect them to be. This is important to do. When you are mocking out a piece of code, you want to make sure that you called that code correctly, right? And so we're making sure that we called request.get with the attributes we expected. And so that's what this does. Final thing about side effect, it's overloaded. If you want to do something weird, like the first time I call this function, I want you to return username 1. The second time I call it, I want you to return username 2. You can do that by setting side effect to an array, and it will iterate through it each time you call it and return the next thing in the array. Let's talk more about mock. So we mentioned this a bit. So you can just create a mock and you can set these attributes on it. So a weird thing about mocks is username1, since it's a mock, I could actually call any function or any attribute of this and it would return another mock. So if I was like, I want username1.hello, it would return a mock. If I'm like, I want username1.get fake function name, it will return a mock. It just always returns a mock, no matter what. So this is just a different way of writing that previous slide. There's other ways you can make mocks. But so if you want to have something a little more specific, so let's say, well, we're mocking out request.response, right? We don't want it to have all these fake functions on it. We really only want to have functions that actually exist on request.response. So we can pass in the class we want to mock out. And that's going to make it so that if you call a function that exists in request.response, it'll return a mock. If you call a function that does not exist on request.response, it'll throw an error. So there's probably, maybe you want a little more flexibility than that. And that is why we have seal. This is new in Python 3.7, and I'm really pumped about it. So you can say let's say you have a use case where one of the things you want to do is you want to assert that a lot of these things do not exist on an object or something. And so you can't have mock pretending things exist that don't exist. So you can use seal. What seal does is it says, okay, any attribute or function that you have not specifically defined prior to this point is out. So if I tried to call like username1.hello now, that's not going to work because I didn't define hello on username1, and I have sealed the mock and said it cannot create any further functions or attributes. Assert called with and call args. So we had on this previous slide, we did side effect, and then we asserted some things about the parameters, in particular that the URL and that the params were correct. So this is such a common use case that there's actually a little bit of easier ways to do it, and you do them with assert called with. There are a couple other asserts. There's like assert called once with. There's a whole variety of them. But the most simple one is assert called with, and what you do is you give it the parameters, and if those are the parameters the function was called with, then it asserts true, and if they're not, it asserts false. And I should clarify, when I say the parameters they're called with, you have to do it in the exact same way. So when we called request.get, we gave it a string, and then we said params equals this dict. So we named one of the parameters, but we did not name the other parameter. And so you have to do that the same way for this assert to pass. Okay. There's also call args. So if you need more flexibility, for example, maybe you want to make some matchers, you want to really just dig into what the call arguments were and only look at a couple of them or something. We have this call args attribute. If you want to compare against call args, what you used to have to do is create this call wrapper around the parameters you wanted to compare against. That or like index into call args, and you ended up with this like really gross looking code. But we have new in Python 3.8, these args and kwargs attributes on top of call args so that you can access them in a much prettier way. Okay, we have 3 minutes left to run the last part. Okay, async. So async, everyone's writing asynchronous Python. It's very awesome. So this is just a rewrite of our previous get username function to be asynchronous. So it's now async def instead of def. We're putting it in a client session instead of doing request.get. We're awaiting everything. So this is our asynchronous version of that function. So how do we test this? The way we test it is with async mock. So unit-test.mock added async mock in Python 3.8. So when you do this patch decorator thing, you want to include new callable equals async mock. And that tells it that your mock should not be a magic mock, it should be an async mock. And then every time you create a mock, you basically just want to make it an async mock again. And so that will let you do your test asynchronously. So yeah, basically we have, we create our async mock, we set the parameters on it all in the exact same way, and then we call get username with await because that's how you call asynchronous functions. And this test works. So the only thing I want to add is we have this pytest.mark.asyncio decorator in here. So what is that? So we didn't really talk about pytest, but it's a really common way of running your unit tests. So if you are using pytest and you have some asynchronous unit tests, they are not going to work by default because you can't call asynchronous code from synchronous code. So in order to make sure pytest is running your async tests correctly, you add this decorator to your test, and then pytest has just got it from there. It knows exactly how to handle it once you have that decorator. Okay. Thank you so much for joining Pyjamas Conf. It was great to meet you. This is pre-recorded. I didn't meet you. It was still great. But yeah, so feel free to connect with me online if you have further questions. I'm on Twitter. I'm also on LinkedIn. Have a fantastic December.